So the specific force sensor that I chose was the FS20 low force compression load cell. And on this page, I found the instrumental errors to be non-linearity error, zero return, span repeat, hysteresis, thermal zero shift, thermal sensitivity shift, zero drift, and creeping. And in order to calculate the values of the instrumental errors associated with that, I chose the range of 0 to 500, and using the percent given multiplied by the range, you can get the individual errors for each one. So I calculated that, and then I couldn't find a resolution on the page given, so I assumed a 0.5 end resolution. I assumed that was good enough. So then, using this equation in order to find the calculated instrumental error value, I did the square root of all the values squared, add together, and I got 6.88. Then the zero order error is 1/2 the resolution, again assumed 0.5. I got 0.25, and then getting the design stage uncertainty, take the square root of your zero order error squared plus your instrumental error squared, and then that's your design stage uncertainty for that specific sensor. And the specific circuit that I found this to be for the analog-based signal conditioning circuit is a current-sensitive Wheatstone bridge. And I think the purpose of it is to present differences in the force range based off of pin configuration, whether the pin's vertical or horizontal, and by that I mean going to here, when the pin is, as you see down here, when the pin is horizontal, you only get a force range of 500, 0 to 500, but when it's vertical, you can get all these when it's vertical. So then, the next question was, if it's connected to the BTH1208LS, in order to find out the overall design stage and uncertainty of this, you kind of follow the same path, but use a different equation. You have your LSB and your FSO in order to find your zero order error, which is actually, this is your zero order error. This is going to be the equation in order to find the instrumental error. So have your FSO at 500, you can plug that into there. Turns out at the three values of 1, 0.5 and 1, the 0.5 ends up, because of the equation being the same, at 0.6. Having those values, with the 1 being plugged in there, it's just 500 over 2 to the 12th, with the resolution being 12. And then using that same equation like we did above, 0.183, and then finding the overall design stage uncertainty, 0.183, plus the error, you'd see is the zero order error, right? And then you just repeat kind of the same process of combining what you got there with the other one, and ends up rounding up for the overall design stage uncertainty to be 6.88.